Okay, in this video we're going to look at two topics: increasing and decreasing functions and the average rate of change. The average rate of change is extremely important, especially when you get to your calculus class. Increasing and decreasing I don't think is that hard. You know what it means. It means the graph is going up. From left to right, the graph has to go up. Now what does that mean? Well, if you have an x value, a is less than an x value b, then the y value of a, f of a, has to be less than the y value of b, f of b. And similarly, if a function is decreasing on an interval, if a is less than b, then the graph is going down, right? That means the first y value, f of a, has to be greater than the second y value for it to be going down. That's all. So let's see. Suppose we have a function, looks like this. This is a function, right? And suppose we want to know when is f increasing. Now you could use closed intervals or open intervals for this. I just always use open intervals. When is the function going to be increasing? Well, it looks like it's going up from -2 to 2, right? And it also looks like it might be going up from 7 to 11. There it is. Now when is the function decreasing? Well, the function would be decreasing from -3 to 2, the function's going down. And then also, I should say -3 to -2. And then also, it's going down again from 2 to 7. So from x equal 2 to x equals 7. Notice we always give the x intervals, right? Where it's decreasing and increasing. Alright, so that's the first topic. The second topic is way more important, I think. The definition of average rate of change of a function on an interval. Again, these are the x values, a to b. Is defined to be f of b minus f of a, so it's the change in y over the change in x. So we've seen this before. It looks a lot like slope, doesn't it? Anyway, so let's see. Suppose I want you to find the average rate of change in this function given by this graph on the interval from 0 to 3. That would just be f of 3 minus f of 0 over 3 minus 0. Well, f of 3 looks like it's about 2. And f of 0 looks like it's about 1. So it'd be 2 minus 1 over 3, which is 1/3. Okay? Let's see. Why don't you try this one? See if you can do this one. Use the graph. See if you can find the average rate of change in the function on the interval 2 to 4. You're going to have to approximate this. So go ahead, hit the pause button. Alright, so that's defined to be f of 4 minus f of 2 over 4 minus 2. F of 4, I'm going to say that's about, I don't know, 1.5. That's what I'm calling it. F of 2 is about 3. So I get 1.5 minus 3 over 2. So my answer is -0.75. Yours is probably a little different. That's okay. As long as you show your work. Here's a harder one. Look at what I want you to find here. I want you to use the graph to find a, so that the average rate of change from 2 to a, this is the x value 2 to x value a, the average rate of change is -1/2. That's kind of sneaky. You see first of all, what does it mean to say the slope or the average rate of change is -1/2? You see this line I have here? Let me get up my ruler. They don't give me a ruler around here, so this is all I could find. It's this piece of cardboard. Anyway, the slope of that line is about -1/2. Can you see that? Because the run is 2 and the rise is -1. So you're going to start at 2 here, and you want to find another value of x, a, where the slope of the line is -1/2. So what I'm doing is I'm trying to draw this so it's parallel to this first line, because I know this line has slope -1/2. If you draw this line, it looks like if a were 5, that would work, right? If a is 5, then the slope from 2 to 5 would be the same as slope as that. So that's what I picked. Again, you're approximating these, so you might get a little different one. Okay, that was fun, wasn't it? Well, let's look at some other. Here's an application problem. This is the graph of cold night. Look at that temperature in Fahrenheit. That is cold. Yeesh. Alright, so the first question is find the temperature at 2 p.m. Well, this is since midnight, so 2 p.m. would be f of 14, wouldn't it? F of 14, which is about right about there, and the y-coordinate would be about 6 degrees Fahrenheit. You see how to read this? So then I want you to find this. find the average rate of change from 6 to 9. Isn't that what this is? The average rate of change from 6 to 9? F of 9, that would be 9 a.m. I'm getting about a negative 5 degrees there. Does that sound about right? At 9? And at 6 I'm reading that to be about negative 13. So when you take the change in y, so you get negative 5 minus negative 13 over 9 minus 6, you actually get 8/3. The units are really important. The units of the average rate of change become degree Fahrenheit per hour, and that tells you what it's representing, isn't it? Isn't this telling you how fast the temperature is increasing? You could actually say it's the average rate of change in the temperature from 6 a.m. to 9 a.m., but for example, if the temperature were to continue to increase at this rate, every 3 hours the temperature would rise by 8 degrees Fahrenheit, right? But here's a hard one. Find a 3-hour interval where the average rate of change is about 2 degrees per hour. So again, I want to find, what does it mean to say 2 degrees per hour? I'm going to say the slope of this line is about 2, isn't it? If you think about what I've done here, the slope of this line is about 2, because the run would be 3 and the rise would be 6, so the slope of this line is 2. So I want to find a 3-hour time interval where the average rate of change has the same slope as that line. So if you just look at this, can you see one that might work? I'm looking at this and I think maybe, what about from 9 to 12? It might not be exactly the same, but from 9 to 12, the slope of that line from 9 to 12 is basically the same as the slope of this. So I'm going to say from 9 to 12. 9 a.m. to 12 a.m. The slope's about 2. Okay, a couple more things here. Let's look at it algebraically now. What if you're given a function given by a formula and you want to find the average rate of change in f of x from 1 to 3? Wouldn't that be equal to f of 3 minus f of 1 over 3 minus 1? Now, f of 3, you plug 3 in, you get this. You plug 1 in, you get this. And 3 minus 1 is 2. So when you simplify, I get negative 4 minus 4, negative 8 over 2, which is negative 4. That's the average rate of change. Here's a hard one. Find a so that the average rate of change of this formula here, this function, f of x equals 5 minus x squared, on this interval, the average rate of change is 3. So what you would do is you would take the average rate of change. You don't know what a is. In fact, that's what you're trying to find. You would take the average rate of change, f of a minus f of 2 over a minus 2, and set it equal to 3, and then solve this algebraically. Now, when you plug this in, f of a becomes 5 minus a squared, right? Remember the function's right here. It's 5 minus x squared. F of 2 is 5 minus 2 squared over a minus 2. So when you simplify that, you get 4 minus a squared on the top, and you get a minus 2 on the bottom. You cross multiply. You get this. Get everything on one side. It becomes a quadratic equation, which factors. So you actually get two solutions. You get a equals negative 5 or a equals 2. But do you understand why a equal 2 is not a valid answer? First of all, you can't have the slope from 2 to 2, the average rate of change. But secondly, if you were to plug it in the original equation, it's undefined. So remember, the solution has to be defined in the original equation. So there's only one value of a that would work, a equals negative 5. Alright, well, see if you can do this. See if you can find, go ahead and hit the pause button, see if you can find the average rate of change in f of x on x to x plus h. I'll give you a hint. Your answer is going to have an x and an h in it. Remember the function? The function is f of x is 5 minus x squared. So go ahead and do that. Hit the pause button. We'll go over it in just a second. Okay, does that look familiar to you? Isn't that just the difference quotient? F of x plus h minus f of x over h. So the difference quotient is exactly the same thing as the average rate of change. Same idea. So when you plug that in to the function, this is your f of x plus h. This is your f of x over h. I'm going to go quickly here because we're almost out of time. You may have to hit the pause button. You multiply out x plus h squared, and then use the distributive law. Combine like terms. And you get this, then you factor the h out, cancel the h. Final answer is negative 2x minus h. Gotta go. Bye-bye.